Dear children, in the previous class we have studied about the orbitals, that these are the regions where chances of finding the electron is maximum, and there are some regions where chances of finding the electron is almost nil, that are known as nodes. Today I'll explain you the quantum numbers. The quantum numbers are just like the postal address of the electron. By knowing all these numbers, we can know that where exactly the electron is. What is the size of the orbital, its energy level, the orientation, etc. There are 4 numbers which together known as the quantum numbers. The first one is the principal quantum number, second is azimuthal quantum number, third is magnetic quantum number, and the fourth one is the spin quantum number. The first 3 explains about the orbital and electron both, but the fourth quantum number, that is the spin quantum number, is only for the electrons, because electrons are only spinning in the orbital. Let's discuss each quantum number one by one. Principal quantum number, represented by small n. It is the main quantum number. Its permitted values are 1, 2, 3, 4 and so on. It can never be 0. It explains the energy and the size of the shell. This quantum number was proposed by Bohr. It determined the energy and the size of the orbital where electron is present. The maximum number of electron in an orbit represented by this quantum number is 2n square. No energy shell in atoms of the known element possesses more limit 32 electrons. It gives the information of the orbit, that is k, l, m and n. Angular momentum can also be calculated using principal quantum number. Second quantum number, that is azimuthal quantum number, represented by small l. It was proposed by Sommerfeld. It determines the number of the subshells or the sublevels to which electron belongs. It tells about the shape of the subshells. It also expresses the energy of the subshells. The energy of the S subshell is less than P, the energy of the P subshell is less than D, and the D subshell has lower than the F subshell. The value of L is equals to n minus 1, where n is the principal quantum number. Let me give you an example. Suppose the value of n is 1, then the value of L, that is azimuthal quantum number, will be 0. If the value of n is 2, then the value of L will be 0 and 1. The maximum number of electrons in the subshell will be given by the formula 2 into 2L plus 1. The S subshell can accommodate maximum of 2 electrons, P subshell can accommodate 6 electrons, D can accommodate 10 electrons and F subshell can accommodate 14 electrons. For a given value of n, the total value of L is always equal to the value of n. The third quantum number, that is magnetic quantum number. Its symbol is small m and a subscript, that is small l, on the right hand side. It was proposed by Zeeman. It gives the number of the permitted orientation of the subshells. The value of m varies from minus L to plus L through 0. For example, the value of L is 0, then m will also be 0. If the value of small l, that is azimuthal quantum number, is 1, then magnetic quantum number will be minus 1, 0, plus 1. If the value of L is 2, the value of M will be minus 2, minus 1, 0, plus 1, plus 2. For a given value of N, the total value of M is equal to N square. For a given value of L, the total value of M is equals to 2L plus 1. The last quantum number is the spin quantum number. This is only for the electrons. Its symbol is small m with the small s on the right hand side as a subscript. It was proposed by Goldschmidt and Uhlenbach and denoted by the symbol of Ms. The value of Ms is plus half and minus half. These values shows that electrons are spinning either clockwise or anti-clockwise. I hope the quantum numbers are very much clear to you. Now let me proceed further and let me explain that how these orbitals are filled, how these electrons enter these orbitals. What are the rules which are governing the filling of these orbitals? There are 3 rules: the Aufbau principle, the Pauli's exclusion principle and the Hund's rule. The Aufbau principle. The Aufbau meaning the building up. According to this principle, if we have the orbitals of the various energies and they are vacant, then the orbital with the lower energy will be filled first. That is, the Aufbau principle states that the orbitals are filled in the order of increasing energy. The orbital with the lower energy will be filled first and the orbital with the higher energy will be filled later on. This is the series by which we can make it out that which orbital will be filled first. They are in the order of increasing energy. 1s orbital will be filled first, then 2s, 2p, 3s, 3p, 4s and so on. The Pauli's exclusion principle. This principle states that an orbital can accommodate maximum of 2 electrons. That is, an orbital can have the 2 electrons and the 2 electrons cannot have the same set of 4 quantum numbers. If the first 3 quantum numbers are same, then the 4th quantum number, that is the spin quantum number, will be different. Let me explain why. That one electron will be spinning clockwise and the other electron will be spinning anti-clockwise. The one electron will have the plus half value and the other electron will have minus half value. So we can say that no 2 electrons in an atom can have same set of 4 quantum numbers. Hund's rule. Hund's rule says that if the orbitals of the same energy are available means that they are all vacant, then first they are singly occupied and then the pairing starts. The 4th point which we have to remember while filling the electrons in the orbital is half-filled and fully filled orbitals are extra stable. It is due to the symmetrical distribution of electrons and the exchange energy. Here I am explaining you the 4th point by taking 2 examples, chromium and copper. Chromium, atomic number 24. As per keeping in mind all the first 3 rules, that is the Aufbau principle, Pauli's exclusion principle and Hund's rule, the electronic configuration of the chromium comes out to compensates that energy requirement. The another example is copper, atomic number 29. Let's see its electronic configuration as per the three rules: 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2. It is incorrect again, because after transferring one electron from the 4s orbital to 3d, 3d becomes 3d10 and then it becomes more stable. Dear children, so while writing the electronic configuration, we have to keep all these 4 points in our mind. Now, simultaneously I will explain you the quantum number and the filling of electrons and how these elements are placed in the periodic table. You can see the 1s orbital. The value of the small n, that is the principal quantum number, is 1, L is 0, 0 means S subshell, the value of magnetic quantum number is 0 and the spin quantum number will be plus half or minus half. Now you can see that one electron in the 1s orbital and the atomic number 1 is for hydrogen. You can see the place of hydrogen in the periodic table. This one electron is in 1s orbital and I have already explained you in the previous class that s orbital is spherically symmetrical. Second electron, it again entered the 1s orbital because one orbital can accommodate 2 electrons and you can see the direction of the arrows. One is spinning in the clockwise direction and the other is spinning in the anti-clockwise direction. Atomic number 2 is for helium. Helium is placed in the 18th noble gases. The value of the principal quantum number, that is small n, is 2. L, that is the azimuthal quantum number, the permitted values are 0 and 1. The third electron entered the 2s orbital. Now in total there are 3 electrons, 1s2, 2s1. The atomic number 3 is for lithium. Now you can see the position of the lithium just below the hydrogen and you can see that the size of the s orbital is increased because the value of the principal quantum number is now 2. The 2s orbital is larger than 1s orbital. One more electron in the 2s orbital because the maximum capacity of the s orbital is 2 electrons. 2p orbital. There are 3 orbitals in the p subshell and p orbital can accommodate in total 6 electrons. We will see one by one and we will also see the change in the shape of the p orbital. I have already told you the p orbitals are dumbbell shaped. You can also see that all these elements like boron, carbon and nitrogen, how they are placed in the periodic table. You can also see the p orbitals, these are dumbbell shaped. While writing the electronic configuration, as per the increase in the atomic number, the number of electrons will be increasing.